Okay, let's just start and hope they join during the class. So, yeah, so this is second session. Somebody had asked a question in the last session regarding a GATE 2012 question. Was somebody able to solve it? They had put it up on the group also. I have it here. We will solve it together today. Before that, this is just a recap. We'll just do this before every session so that you have you recall what we did in the last session. So we discussed about the aerodynamic center. Now you're very comfortable with it. The aerodynamic center for the entire aircraft is called the neutral point. Then we know trim conditions. It is relating to equilibrium. Then you have the basic pitching moment equation, and what is the we know what is the only condition to ensure longitudinal static stability. That is the slope of this equation, dcm upon d alpha should be negative. We know how to ensure cm not greater than 0. That condition is not necessary for stability. It is only to trim the aircraft at positive angles of attack. Okay, then I think we still have some equations. I think with 2-3 slides just to recap the equations and what equations we'll be using for the questions. So you have the wing contribution towards Cm naught and Cm alpha, tail contribution towards Cm naught and Cm alpha. And you have the definition of neutral point, which we just discussed. And we have static margin, which is just a quantitative measurement of how stable your aircraft is. It's a distance between the neutral point and the CG. Yeah, so these were the equations that we use when we solve the question. So one thing we need to make sure is that one thing you need to remember is that all of these equations, all of the quantities in these equations are valid for radians and per radians. Now, depending on the question and depending on the values given in the questions and what they've asked you and what unit they've asked you in, you can convert it into degrees and per degrees. But these equations are inherently derived for radians and per radians respectively. So keep that in mind. Then I think we have a slide on controls. Yeah. So how we introduce controls and why it's necessary. So control do not change the stability properties of the aircraft in any way. It is only to maneuver the aircraft. So deflection of control surfaces just translates the graph. It does not change the slope of the graph. Okay, so it just changes the y-intercept of the graph. So it just moves the graph across the plane. It does not change the slope. If the slope does not change, the stability does not change. Then the conventions that we saw, elevator deflection down is considered positive. When you deflect the elevator down, you have a positive increase, a positive change or an increase in the lift. So your CL delta E is positive. That is, change in lift with change in elevator deflection is positive. But due to this positive change in lift, there is a pitch down moment, which is why your CM delta E has a negative sign. Then we saw our delta E trim equation, that is how much we need to deflect the elevator to trim it at different CL trims. So when you translate the graph, what happens is that your CL trim changes. The value at which you want to trim your aircraft changes. Okay, so how much we need to deflect our elevator to trim at different CL trims is given by this equation. Yeah, so this was the question that somebody had brought up last class. Was somebody able to solve this, or do you want to try solving it now? Just write down all the quantities available to you, and then we'll try solving it. So take maybe a couple of minutes and try to solve this, and then we'll solve it together. Okay, have you been able to solve it or have you started? Can you tell me what approach you took and how far you've gotten with that approach? And then we can see how to go about it. How did you start? What was your thought process? How did you start and till where you've reached or where you're facing the difficulty? All right, okay. So they've asked you, what have they asked you? The maximum distance that the center of gravity can be behind the aerodynamic center without destabilizing the wing tail combination. So we have seen questions where we saw what is the aft limit of center of gravity. So what this question is basically asking you is to find out neutral point, right? Is that much clear? The maximum distance that if you move the center of gravity beyond neutral point, the aircraft is unstable. So maximum distance is neutral point. Now they've asked you the distance between neutral point and AC of the wing. So what have they asked you? They've asked the quantity that is required is uh, so they've asked for XNP minus XAC wing. This is what is required. Now, in one of the derivations, I think in the first demo session where I had taken, we had derived the neutral point, right? So, neutral point equation, one simple way that I used to remember is so if you have neutral point x bar np is x bar np, if there was only wing, what will it be? It will be the xac of the wing, right? So, if you have only the wing, x bar np is x bar ac of the wing. Now, as and when you add more aerodynamic surfaces, this neutral point gets shifted backwards and forwards. Correct? So, if I add one tail, it is pulled backwards. By how much? So, you pull it backwards, subtract. What do you subtract it with? Cm alpha of the tail by Cl alpha of the wing. Okay, so this is one simple way to see. So it's something like a weighted averaging. So you're pulling it back by some amount. Now, suppose we want to consider the fuselage contribution. So what do? You do minus Cm alpha of the fuselage by Cl alpha of the wing. So as and when surfaces are added, you keep adding these terms. It starts with aerodynamic center of the wing. When I add another surface, you subtract that quantity and then you subtract the next quantity, so on and so forth. Okay. So this is one way that I used to remember these equations. So in this question, we have wing and tail. So let's consider only these two quantities. So for this question alone, we are not considering, just a minute. One minute. There is some issue with my pen. Just give me a minute. Okay, yeah. So just for this question, our equation will be x bar np is x bar ac wing minus cm alpha of the tail by cl alpha of the wing. All right. So now let's proceed, and then we need to find out the difference between this, right? So what is Cm alpha of the tail and what is Cl alpha of the wing. What is Cm alpha of the tail? Let me write this equation again. X bar np, I'm just rewriting it. X bar AC of the wing is minus Cm alpha of the tail. Right? Cm alpha of the tail, what was the formula? It was the wing contribution towards Cm alpha, right? So we had just gone through this equation. I will write it down now. So it is minus VH, horizontal tail volume ratio. Then you have eta of the tail efficiency factor. Then you have Cl alpha of the tail by Cl alpha of the wing. And you have 1 minus dou epsilon by dou alpha. Right? I hope you remember this. Okay. So now we just need to find out these individual terms and substitute it. So eta tail is given in the question. Cl alpha tail, Cl alpha wing, they've given that the wings are geometrically similar. So Cl alpha of the wing and the tail are the same. Then dou epsilon by dou alpha is given here. That's it, right? So we need to find out VH. What is VH? VH is ST upon S into LT by C bar. Now LT is not given to you here directly. What is given to you? LT, what is given? See, this is, distance between the two aerodynamic centers is equal to semi wingspan, right? So since LT is not given to you and you don't have any other indication of CG, just take this distance to be LT. It will be slightly different, but we can just assume this because look at our options, they are in single decimal value, so they do not require such precision. So just assume LT to be the same distance, correct? So ST upon S is 1 by 3, correct? LT is semi wingspan, B is 30, so it is 30 by 2, and C bar is 2.5. How much does this come to? Yes, Dharmesh, tell me what is Cm alpha for wing. Look at the details given in the question and tell me what is Cm alpha for the wing. Okay, yeah. So VH is 2, correct. What is Cm alpha for the wing? Cl alpha, you asked Cl alpha, sorry. What is Cl alpha for the wing? It's given in the question, right? What is Cl alpha for wing? Exactly, 0.08. So now try to find out XNP minus XACW. Just substitute all the quantities. Now only VH was missing that we have now. Just substitute it. So just substitute all the terms. We get 2, eta tail is 1, Cl alpha tail, Cl alpha wing are both same. So 1, then 1 minus 0.3. So I'm getting 1.4. Now, I'm not sure who brought this question. Do you know what the right answer is to this question? I'm not sure if we have the answer key with us. Because what they've asked in the question is the distance between the center of a neutral point and aerodynamic center of the wing. So what we've gotten here is the ratio between this distance and C bar. So ideally we should be multiplying it with C bar to get the answer in meters. So if I do 1.4, so this is x bar NP minus x bar AC wing is 1.4, is 1.4. Now if I multiply it by C bar, I will get, so x NP minus x AC wing is 1.4 into C bar. So I'm getting 3.5, right? 3.5 meters is what we are getting. Now, can somebody tell me if we have the answer to this question available? This is GATE 2012 question, question number 76. Can you explain it? So the question is maximum distance that the center of gravity can be behind the aerodynamic center. So what is the maximum distance that the center of gravity can go to till the aircraft is stable? So if the center of gravity crosses neutral point, the aircraft becomes unstable. So neutral point is the maximum limit till which your CG can travel. Correct? Yes. Okay. So if you have the answers, please confirm and let me know if it's 1.4 or the closest is 3.4 meters. I still believe we should be getting 3.4 meters because uh, we need to multiply it by C bar. Do confirm it if you get the answer key. I will also try to get the answer key, but you know, now you understand how to approach this problem, right? I hope that much is clear. Okay, let's go to the next question. Next question is along similar lines, but they'll ask you for a little more details so that this concept is thorough in our heads. So now that you've done this question, we should be able to, yeah. So now look at the question given here, what details are given here. It's very similar to this gate question, but it is a little more elaborate. You'll have to do a little more calculations, okay? So for an aircraft, the tail area is 1/4 of the wing area, and distance between the two aerodynamic centers is equal to half the wingspan, and the wing and tail are both in rectangular shape. And then you have additional data. You have CL alpha of the wing, CL alpha of the tail. Then alpha at zero lift, then C bar, wingspan, CMACW, eta tail, CMAC of the tail is 0. The distance between CG and AC of the wing setting angle, tail setting angle. Okay, so these are the data that's given to you. Then the question is the pitching moment coefficient at 0 degree angle of attack for the wing will be. So what is the quantity that they're asking? How do we denote this pitching moment coefficient at 0 degree angle of attack for wing? What is the quantity that they're asking you? Pitching moment coefficient is Cm. At 0 degree angle of attack, Cm naught. And for the wing, so it's Cm naught W. So they're asking you for Cm naught W. This is what is being asked. Now do refer to your notes, or if you remember the equation, try and find out Cm naught W. It's a direct substitution of the values in the equation. Let's try doing it. So I'll just write the equation, maybe that will help you. Cm naught contribution of the wing. Okay, so these are the terms that are independent of the angle of attack from the Cm equation. So it's Cm is C wing plus Cl naught Cg by C bar minus x is C wing by C bar. Okay, so now I hope this will help you solve how to solve it. Just try doing it and then we'll do it together. Okay, so you've gotten A. Let's just solve it and see if we get the same answer. So, yeah, before that, we need to find out CL naught. How do we find out CL naught? Alpha naught is given to us, alpha at a zero lift. Just multiply it with the slope. Okay, so it is 0.09 into 2 degrees. Okay, so that will give you your CL naught. Okay, so let's just proceed. CMAC wing is minus 0.009 plus CL naught was 2 into 0.09, and then this distance is directly given to you as 0.03, and then substituted you get 0.0036. Correct. Okay, let's go to the next question. The pitch stability derivative of the wing in per radian will be. Now what term are they referring to? First was Cm naught wing. Now what will it be? What quantity are they asking you to find? dCm by dCl. Is that what they're asking you? They're asking Cm alpha of the wing. This is what you need to find out. Try doing. You've gotten C. Okay. What about Adarsh? I have you. Can you Have you started solving it? Can't get. Okay, can you tell me where you're facing the difficulty? So we need to find out CM alpha wing. Okay, so where are you facing the difficulty? So you remember the complete equation, right? The complete wing contribution equation. From that, we need to take out the terms that are dependent on alpha. So let me go back to that slide. Yeah. So these equations you're comfortable with. Do you have these equations with you? The wing contribution, tail contribution. Yes. Okay. So now this is what we found out in the first question. That is CM naught of the wing. This is what they're asking you now. CM alpha of the wing. This is CM naught of the tail, and this entire thing is CM alpha of the tail. Okay. Yeah. So this is what they're asking you for now. Correct? CM alpha of the wing. So now you have that equation. Now can you try to find out? So this is what you need to do. You need to take CL alpha, multiply it with the distance. That's it. Can you tell me the answer now? Yeah, sure. Once. So I'll just write it down for completion's sake. CM alpha wing is CL alpha wing by XCG by C bar minus X AC wing by C bar. And that is 0.09 into 0.03, which gives you option C. Okay, let's go to the next question. Yeah, the value of downwash angle at 5-degree angle of attack will be. So downwash angle is your epsilon, right? So that is given by epsilon naught plus epsilon by alpha into alpha. Now this is given as 5 degrees. So you need to find out epsilon naught, then find out the slope, multiply it with the angle of attack, and then you add the two terms, you'll get the complete angle of attack, complete downwash angle. Try doing it. Okay, what about others? Have you started doing it? I will help you with the equations, so maybe then you can proceed. So first equation that we need to use is epsilon naught, and that is given to you by 2 CL naught by pi E A R. Okay, so all of these terms you do have with you, right? Yeah, all of these terms are available. Okay, next is the slope. Dou epsilon by dou alpha. Actually, d epsilon by d alpha with the direct slope. That is 2 CL alpha wing by pi E A R. Okay, now just try substituting the terms. Minus 2. Uh, I don't think there is any way you can get a negative sign, right? Adarsh, how did you get the negative sign? Can you tell me what? Okay. Is it 2? Just try doing it again. It's approximately 2, yes. Okay, so let's just write it down for completion's sake. Before the aspect ratio is b squared by s, and it's, I think it says it's a rectangular shape. Yeah, so it will just be b by c, which is 26 by 2.2. Okay, so now we can substitute the terms here. 2 into 0.18 by pi, so ratio is 26 into 2.2. So I'm just writing it directly. And then again, this gives you in radians, right? So you multiply it by 57.3. This comes to 0.555 degrees. Okay, correct me if I'm going wrong. Here you have 2 into 0.000. Okay, let me just write that again. 0.09, and then you have pi, aspect ratio is 26, 2.2, and again we multiply it by 57.3, and you get 0.2778 degrees. Now you plug it into this equation and you get 1.944 degrees. Okay? Alright. Okay, now let's just look at the next question. Radians? How is it radians? They've asked in degrees, right? Just a minute. I just a minute. So the equation was originally in radians. We converted it to degrees, right? Let me just go back to it. So equation is all initially in radians and we converted it to degrees. Okay. Alright. Okay. Let's go to the next question. The pitching moment coefficient at 0 degree angle of attack for tail will be. This is similar to the first question. Uh, what is the quantity they're asking you? What is the representation? How do we denote it? CM not tail, correct. So now try doing it. They've asked for CM not tail, okay? Others, right? Is CM not tail. So at 0 degree angle of attack. So again, just go refer to those equations in the first slide and the CM not tail. Yes. Try doing it. I hope you remember the equation, right? Okay, let me write down the equation. VH CL alpha tail I wing plus epsilon naught minus I tail. Now what is missing here? We don't know VH. So let's find out VH. What is the formula for VH? Just write it a little below so we can substitute it later. ST by S, LT by C bar. Now this is similar to the gate question where LT is not given to you. They've given you distance between the two aerodynamic centers. But in this question, they have also given you the distance between CG and AC. So you can ideally find out LT. So let's try doing that. Though I'm not sure if we'll have place here. Okay, let me just Okay. LT is X AC tail minus XCG. Right? So let's just take LT by C bar, the whole thing, right? So it's something like this. And that is X AC AC tail minus X bar AC wing minus X bar CG minus X bar AC wing. Correct? So now we just substitute the terms. This is given to be as half wingspan, so it's B by 2 by C bar minus this is directly given to as 0.03. So you get this value as 5.879. So I'm just going to plug that in here. So ST by S is 1 by 4. This is 5.879. And if you get 1.469. Am I doing it correct till here? Dharmesh, have you gotten the same value? Something similar? You can also take LT to be B by 2 just like the previous case, but I thought since the data is already given to us, we can use it. Okay, how much did you get VH to be if you took B by 2? Alright, okay, let's just see if you're getting similar answers. Okay, now I plug this in back here. I get 1.469. Eta tail is 0.89. CL alpha tail is 0.059 per degrees. And all of your angles are already in degrees. So 1.3 plus epsilon naught we had found out in the previous slide. 0.555 minus tail setting angle. Okay, try solving this. I'm getting 0.243. Dharmesh, have you taken the same similar values except B by 2? Everything else is same? How can it be so different? Can you just calculate VH and tell me just ST upon S? Okay, let's just do that here. It'll just be 1 by 4 into B by 2. B is 26 by 2 into C bar is 2.2. That will be
You are currently the only person in this conference. You are currently the only person in this conference.
Okay, I think there was some issue with the net on my side. Can you please recalculate and tell me uh, what you've gotten? Is it somewhere close to 0.243? All right. Okay. So it's 0.24. I'm also getting something similar. Okay, let's move on to the next question. Yes, did you have a question? Or do we know which unit to give our answer? All right. Okay, so in this equation, if you take your CL alpha tail to be in per degrees, you need to make sure that your angles are in degrees. But if you convert your CL alpha tail to per radians, then you convert your angles also to uh, radians. So it will cancel out, right? You just need to make sure that CL alpha tail and your angle are in the corresponding units. Rest of the things will cancel out on its own. You will still get the same numerical value. So if you're converting your angle to degrees, then you use your CL alpha tail to be per degrees. If you're taking your angle in radian, then CL alpha tail should be in per radians. And they will cancel out and you will get the same numerical value. Right? Alright. Okay. So let's go to the next question. The pitch stability derivative of the tail in per radian. Here they're asking you CM alpha tail. CM alpha tail. Okay, again refer to your equations and try solving this. Okay, let's see if B is the right answer. We write down the equation. Minus VH eta CL alpha tail 1 minus 2 epsilon by 2 alpha. Okay. VH we have just calculated 1.469. 1.47, let's just take it. 1.47. Eta tail is 0.89. CL alpha tail 0.059. We'll convert it last into per radians. Okay, you can do whatever is comfortable for you. I'm just doing it this way. And 1 minus, what was the slope? 0.277. Alright, so I'm getting minus 0.056 per degrees, and now we need to multiply it with 57.3 to get minus 3.21 per radians. Okay, so the right answer is option C. You need to be very careful when you look at the units. Right, so they've asked you in per radians. So the right answer will be minus 3.2. How 2.778 came? Okay, in the previous question, yeah, here we had already calculated d epsilon by d alpha, right? I just took 0.2778 from there. Yeah, and that is a slope, so it has no units. Okay, and we had solved it using radians, so it does not have a unit. Okay, this should not be degrees. Yeah, it's a slope. All right, let's go to the next question. If the fuselage contribution to Cm alpha is equal to 0.99 per radians, the difference between neutral point and aerodynamic center of the wing will be. So we had in the first question from the GATE 2012, we had solved something similar. Here there is one additional term. Try solving it using the same method as we solved the GATE 2012 question. Try solving it and then we'll do it together. So I'll just write the equation. I did mention this in the first question, but I'll just write it again. So x bar np initially starts off as the x bar AC of the wing. So x bar AC wing. And as and when you have aerodynamic surfaces, you subtract it from that. You have minus Cm alpha of the tail, right? So Cm alpha of the tail is minus Vh eta Cl alpha tail by Cm alpha tail 1 minus dou epsilon by dou alpha. Next is the fuselage. So minus Cm alpha of the fuselage by Cl alpha of the wing. Okay, so now you have the equation. All the terms we already found out. Just substitute all of them, and Cm alpha of the fuselage is given in the question. And make sure that you remember it's given in per radians. Right, so just make corresponding units. Have you been able to solve this? Okay, let's try doing it. So I'll just rephrase that. X bar in P minus X bar AC wing. That's what they've asked you to find out. Is equal to minus of minus VH. VH we got as 1.47. I'm just going to take that B by 2 value and proceed. Okay, so yeah. And eta is 0.89, 0.059 by 0.09, and 1 minus 0.277. Correct? So this was the first term, and then you have minus 0.99 by 0.09. That's in per radian, this is in per degree, so I'm just going to divide by 57.3. Alright? Just make sure your units are compatible, that's all. Alright. Either you convert the per radians to per degrees or per degrees to per radian. Okay, so this entire thing should be unitless. The entire term should be unitless, right? Okay. So now when you substitute, what do you get? So 0.622 minus 0.19919 comes to 0.4305. And now multiply it by C bar. So X NP minus X AC wing is 0.4305 into C bar. C bar is 2.2. So 0.947. Adarsh, I think you have stopped at X bar NP minus X bar ACW. They have asked for the distance between these two, right? In meters. In meters. So I think I have, okay, so that was not mentioned here, but the distance between the 2 points, and it should be in meters. I think I have missed that in the question. I'm sorry about that. But you just have to multiply it by the mean aerodynamic chord to get the right answer. You've gotten correctly till the X bar and P. Just multiply it by C bar to get 0.947. All right? Okay, let's go to the next question. What is the delta E required? That is the elevator deflection required to trim the aircraft with a static margin of 10%. CL trim is 0.2. CM delta E is -1 per radians. Delta E naught is 0.05 radians. Just directly substitute these values into the equation and you'll be you'll get your answer. All right, A. Let's just I'll just write it for completion's sake. Delta E required is minus. Okay, I'll just write delta E naught because we've given the value directly, plus static margin by Cm delta E into Cl trim. Delta E naught is 0.05. Static margin is 10%. Cm delta E is minus 1. Cl trim is 0.2. So it's 0.03. Got in the right answer. Okay. So next question, they've given you some data and we'll be using this data for some 2-3 questions. So look what they've given you. They've given you, it's a flight test that's performed at different speeds. Okay, so at 100 meters per second, 140 meters per second, and at various angles of attack, and what is the CL trim, and how much the elevator was deflected to trim it at this different CL trim, and what was this, it was flown at 2 different CG values. Okay, so this is the data that's given to you. And they've given you a lift curve slope of zero point 0.1 per degrees. Question they've asked is, what is the value of stick fixed neutral point? Now we use the same equation that we used in the last question. Okay, that is the hint that I'll give you. Delta E trim is delta E naught plus x bar np minus x bar cg. This is nothing but the static margin. I'm just writing it in this term because they've asked us for x bar np by cm delta E and cl trim. So now we have this equation and we need to find out x bar np. Stick fixed neutral point is x bar np. You have 4 equations and you have 4 unknowns. So try solving it to find out x bar np. Right? What are the 4 unknowns? We don't know delta E naught. We don't know x bar np. We don't know cm delta E. Okay, you have only 3 unknowns. So delta E naught, x bar np, and cm delta E. You have 3 equations. You have 4 equations and 3 unknowns. You should be able to solve it. So the way I did it is I took two sets of data and formed 2 new equations and then solved it. But you can use whichever way you're convenient using it and try solving it. So you have 4 equations because you can apply the same equation to 4 different sets of data, and you have 3 unknowns. You need to find out one of those unknowns, x bar and p. Try solving it. I hope you're able to proceed, right? So the elevator deflection upwards is negative, downwards is positive. So this is negative, this is positive, this is negative. Okay, that's zero. Down is positive. According to our convention, it is that way. Okay, so I'll just do it the way I solved it. You can use any way to solve these simultaneous linear equations. I'll just show you the way that I did. So I'll just take each set of equations. So the first case is minus 3 equals delta E naught plus x bar np minus 0.3 by cm delta E into zero point 0.5. Next is 1 equals delta E naught plus x bar np minus zero point 0.3 by cm delta E into zero point 0.3. Subtract these equations, and I'm not doing the complete derivation, so you get, and after solving it, just rearrange it, and then you get x bar np is zero point 0.3 minus 20 cm delta E. Okay, so this is one equation. Next, I apply the same method to the second set of points. So you get 0 equals delta E naught plus x bar np minus zero point 0.4 by cm delta E into zero point 0.4, and you have 1.5 equals delta E naught plus x bar np minus zero point 0.4 by cm delta E into zero point 0.1. Right? Again subtract it, and I'm again writing the final equation. Okay, so you get x bar np equals zero point 0.4 minus 5 cm delta E, right? Now these two equations in boxes, you can solve these two to get x bar np. Right? Now it is straightforward, right? So you have two equations, two unknowns. It's very simple. So I'll just write the final value. X bar np I'm getting as 0.433. Okay. Is this clear? Have you used some other method? Should we wait for a little while for you to solve yours and see if you're getting the right answer? All right. Okay. So do try this out on your own. Try different methods, whichever is convenient for you. This is what I found easy. All right. Let's go to the next question. Most aft location of CG such that the aircraft has a minimum static margin of 5%. This should be easy now. We found out the neutral point. Now they've asked you most aft location of CG such that stability margin is 5%. this slide. Okay. All right, now try to solve this. See, okay, let's just see. So static margin is x bar np minus x bar cg. Static margin is 0.05. X bar np is 0.433 minus x bar cg. So it's straightforward from here, right? All right, let's go to the next question. Yeah, so answer is C. So next question. It's similar, right? So they just asked you for static margin of 10%. So you can quickly do this. What is the right answer? Right, okay. Let's go to the next question. All right. The aircraft total weight. So they've given you the total weight of the aircraft as 1245.75 kgs and wing area of 17.075 meter square with center of gravity position, that's x bar cg, xcg by c bar is zero point 0.3. So this is the data that's given to you. Now let's see the questions. Okay. Uh, the stick fixed neutral point will be. How do we do this? So we know that static margin is the negative of the slope of minus dcm by dcl, and it's also equal to x bar np minus x bar cg. So this is a graph that is between cm and cl, right? The slope is same. You're just deflecting the control surfaces, but the slope remains same, and the graph is just translated. So slope is same. dcm by dcl is same. So if you find out this dcm by dcl using the data, and x bar cg is given to you in the question as zero point 0.3, then only unknown is x bar np. So can you try doing it? So I think I'll go to the previous slide where the graph is more visible so you can see the scale and everything. So I hope the question is clear. Can I go to the previous slide so that it's clear? You just have to find out the slope. Pick any line, find out the slope. Just take any line, the slope is same. Okay, so I'll take the last line, okay, because I think it's easiest, the pink line, okay? So and we need to find out the slope, correct? So this distance upon this distance, correct? So that is your slope. How do we do it? First, we need to find out the scale, correct? So you take individual divisions. So you have, let me just do y scale. So we'll take this quantity. So you have minus 0.15 minus of minus 0.2 divided by how many divisions are there? There are 5 divisions. So you get 0.01. So each division corresponds to 0.01 increase. Okay. So now what will be this entire quantity? So you just see how many divisions are there and then you can find out. And it should, okay, I made a mistake here. I'll just draw that again. It's from here till the second last division. It's still here. Correct? I hope I'm making sense. So the slope will be uh, dy by dx. I'm just taking the difference in y axis and difference in x axis. Now difference in y axis will be, so you take this quantity and add 3 divisions. So you have minus 0.15 minus 3 into, okay, the slope. Why isn't this writing? Slope was 0.01. Okay, divided by dx. Dx is fairly straightforward, correct? So it's just 0 minus 1.2. So we get, what do we get? We get minus 0.15. Correct? So now we'll plug it into this equation. So it's the negative of the slope. So you have 0.15 equals x bar np minus x bar cg, which is 0.3. So x bar np is 0.45. Okay, so you pick any line, find out the slope, and then you use this equation. Is that clear? Okay, so I think this is becoming too much for one session. So we'll take up, there are some more questions with the same data, same graph. There are some more questions that need to be solved. So we'll take up the same question again in the next session. All right? Okay. So we'll solve the same question again and then we'll see the other questions relating to the same set of data. So do you have any questions? All right. Okay. So we'll meet again for the next session. We'll take up the same question. All right. Thank you for joining the session. Thank you.